Anyway, in order to perform all these steps on real-time basis, that too in particular various robotic applications are there. So those things are going to require, rather those requirements are going to vary from a particular application to particular application. One particular method is actually being discussed over here, and of course, some more detailed information is going to be provided at the other level of it. So an image frame is going to be thresholded in order to produce a binary image. What is the meaning behind this? We may get a query. What is going to happen over here is image normally will be with the varied colors, not only the various objects that are associated, and there are going to be multiple colors in it. In the process of threshold, what they try to do is they try to convert that to a binary image. Means that entire image is going to be converted in the form of black and white. Few figures of that kind I'll show you in the next proceedings. Right now, take it granted that a color thing, maybe even in your MS Word, if you want, selecting an image and you can change the color of it into purely black and white manner. That is possible. Imagine that that is a kind of threshold mechanism that has been applied. For all these things to happen, they try to take the support of some kind of coding, some algorithm techniques they try to, and some coding they try to apply to identify that particular pixel and surrounded by what all available. So even that particular technique is going to be a part of this. And then various feature measurements will further reduce the data representation of the image. So in image, when you are trying to represent, we can either take the support of each and every pixel that is being occupied in it. So for example, in your photo, you may have this particular cell phone, this entire thing, shape if you confirm. Okay, this particular shape of the object is actually this if you confirm, area. Then the what do you call the data that is really required to provide the information about this particular image of cell phone will be reduced. That way, features, say a particular image is going to have certain features, say something like certain diameters, maybe length, breadth, area, something like that. Those features are going to be taken up at the time of reducing the data representation. That is how the total data that has to be manipulated is going to be reduced, so that the process time is going to be minimized. So this particular data reduction is going to change the representation of a frame from, you can read this, you can understand this, several hundred thousands of bytes of raw image data. They have not quantified how many hundreds of thousands of data. It can be many hundreds. It's all depending upon the image and resolution, whatever you are trying to. So to quantify that, to give a visualization for that, how the data can be reduced, or how or by what extent the data volume is going to be reduced, that has been indicated here, stating that from several thousand bytes, from several 100,000 bytes of raw data is going to be reduced to several hundred bytes, several 100,000 bytes to several hundred bytes. Such a great reduction in the volume of data is going to be managed in the process of data reduction, so that for any process and for any further process and analysis, when you are trying to handle, it is going to reduce the volume of data what it needs to handle. Rather, the matrix size of data, whatever it is trying to handle, is going to be regulated. Anyway, that is how we will be in a comfortable position to reduce the time that is going to take for processing, so that the time required for processing that reduced data is going to be reduced, so that maybe at times immediate actions or reactions, whatever you need to, it gives us a scope to make the robo flexible and react on time. So this is what I was trying to tell you. Thresholding an image, maybe Here, this image is actually having some color. You can identify in this that has been totally converted to either black or white. So anyway, there are various techniques that are used to compute the feature values that can be programmed into the computer to obtain feature descriptions of the image. And soon after getting those descriptions, they are going to not going to keep quiet. Those things are going to be matched or compared with the previously stored values in the computer. It is something like, say, suppose diameter and area. If you're trying to, is that cross-sectional area? Once you once you have started saying that that is a cross-sectional area, then that might be a rod, obviously. Then cross-sectional area diameter it could be, or width and breadth of that particular piece could be, length of that could have to be. So based on the properties, rather the attributes that all we were habituated to use earlier, those attributes are going to be what do you call, in those attribute form, the image is going to be what do you call it, feature data is going to be extracted. Based on that, the image is going to, rather with that particular data is going to be compared with the earlier data, rather the data which was stored in the library. Once it matches with that, then they are going to declare that this is the kind of object is this. Likewise, see here in this particular image, so many objects are there, so many number of trees, and of course this may be snow or something, and there is some other small building over here. So many images of this particular kind are there. So all those images need to be, maybe this may be a part on the bridge, it could be, I'm not sure. Okay. So likewise, every image is going to have so many objects. All those objects need to be compared. It is possible only when you extract the information that need to be compared with the library of information, whatever your system is actually having. Okay. Anyway, when you do all that, okay. So anyway, these descriptors include shape and size characteristics that can be readily calculated from the thresholded image matrix. Thresholded image is this, and the matrix pertaining to this is actually one. See, the basic difference between the matrix pertaining to this and the matrix pertaining to this. For this only black and white, because of that it will be hardly having either 0 or 1 at a particular matrix location. Maybe you might have a matrix of 16 by 16, 256 elements are going to be there. All those 256 elements in the case of thresholded image, that will be either 0 or 1. Whereas here it is not that, because there may be some intensity variation, color variation could be, based on that it can have some other value. Based on that it can have some other value. But it is not going to be on those grounds in the case of thresholded image. In the case of thresholded image, it is going to be either 0 or 1, okay? Anyway, digital image processing in particular, in that thresholding is the simplest method of segmenting the images, okay? From a grayscale image, thresholding can be used to create binary images. So of course, this particular statement is actually being collected from Wikipedia, that's an open source. And even these images I collected from that particular open source only. Now, image processing and analysis, when you want to carry out, in particular, you should be in a position to store prototype objects information. Those informations have to be stored as if they are as if they are all some kind of models, something like you being mechanical people, you all would have used some software for modeling. Maybe the Solve platform is the one, on which we have tried to impart training to the possible extent. At least those who have showed interest, they would have gone through. Some features would have been stored as models like cylinder, okay, some spear, something like that, maybe some gears. If you try to see the mechanical related softwares, design purposes, there are going to be certain standard gear models. Those things will be made available, quarter joints, something like that. Even here, for the sake of image processing and analysis purposes, some prototype objects, like we are going to have an idea on an area using maybe the images that are all concerned with. Keeping those aspects in mind, we are going to build a library. So that library building will be done. That library building will be done during the time of teaching for that robot. See, this particular statement may be something new for you, but you will get acquainted with it when you go on, when you go in depth more and more. See, word may be different. The idea over there is the objects with which our images are going to deal with. All those objects are that informations pertaining to them are going to be stored in a particular location called library with a name called computer models. Okay. So for them also are going to be treated like a feature, and the informations pertaining to them is going to be referred as feature informations. And those feature informations could be area, it could even be perimeter, it could be diameter. Diameter, the moment it comes, it might even deal with inner diameters and outer diameters, or major and minor diameters. It could be on any grounds. So these are all the feature informations pertaining to a particular object. Say for example, if you are dealing with a gear, then what happens? For gear, mean diameter is one parameter, and gear ratio is another parameter, another feature information. Okay, number of teeth or some kind of information, maybe what standards it is trying to follow, DIN or BIN, or what kind of standards your gear is actually trying to follow. So all this information, this kind of informations are being referred under feature informations. All these informations are supposed to be stored in the computer. Okay, so in the subsequent operations, the feature values are going to be calculated for the unknown objects. Like an image has been grabbed, and from that particular image, maybe through segregation, you are able to capture individual objects, and for those objects, computer cannot conclude what type of object it is. So it is going to extract the feature informations of all those objects, and that feature information being extracted are going to be compared with the feature informations in the name of computer models being stored in your computer. Based on the relative comparisons and match that has been formed, it is going to give conclusions that this is the kind of object it is. Anyway, third function is actually the application, and of course few applications we have already seen: inspection, part identification, location and orientation. Everything is actually very, very important, because unless otherwise you are in a position to identify the object location and its orientation, it is not possible for us to give the proper instruction to move that particular robot to a particular location. Moving your robot to that location is not going to finish our job. Your end effector has to be oriented properly. Only after orienting it in a particular manner, it is quite possible for us to, rather for that particular robot to grab or grasp that particular object, held that particular object. So any kind of manipulation it needs to do, it can do only based on that. So for all these things to carry out on smooth grounds, the robo vision system is going to be helpful. And the next area is actually sensing and digitizing functions in machine vision. Image sensor sensing will be requiring some type of image formation device, something like camera and digitizer. Together, nowadays, digital camera, when you try to take up, that is actually acting as a camera come digitizer. Though we call it as a camera, digital camera, that's an indication that that is actually acting as a camera as well as it is trying to digitize that information. And what it is trying to do, it is trying to store a video frame in the memory. See, though it has been stated as computer memory because the robots are being attached through the controller to the computers. So all the information that is going to capture through vision sensor is going to be stored in this set of frames in the computer memory. Okay, so there are certain functions, sub functions that are all associated with this. The first one is actually under that capturing the image of the scene with the vision camera. So when that particular image has been captured, it is going to have the entire scene. The image is going to have the entire scene. Whatever the your camera would have been focused to an area, and that particular camera will be having a particular zone. Within that particular zone, whatever the object is available, all those objects are going to be captured. All those objects are going to be captured. Soon after that has been captured, what it is going to do? It is going to have varied intensity. See, for example, now you can have a watch in a place wherever you are. You try to have a watch of your room, or maybe you might be sitting outside of your building. You can have a watch of your surroundings. When you do that, some portions of your watch would be with less intensity, some portions with pretty good intensity, some portions will be much more brighter. There are variations. That means that there is a change in the relative light intensities throughout that particular scene. Okay, all that particular data also need to be captured. And that particular change is not happening all of a sudden. It is actually varying continuously. That has been referred with a particular term called analog continuous light intensity. Because all that information, whatever you are watching, is not digitized. So whatever you are able to watch through your vision, eyes, that is actually analog information. The camera, whatever you are using, analog camera if you use, that is also going to capture analog information. Digitizer is going to convert that analog information into the digital form. Okay? So in the process of digitizing, it is going to, it is not in a position to convert the data in the same form as it was in the analog form. Okay? So that we will see in the forthcoming slides in some other graph. So anyway, digitizing, when you try to, this particular word you would have used, analog to digital converter. So maybe I could get a chance to use this, and you all are actually able to use through your phone. But earlier, this particular device to convert analog signal being received from one channel or some from few channels to the digital form, it was costing about 5 lakhs. I'm talking about not today's prices. Today the prices would have gone down, and even the accuracy of the data being collected also would have increased. I'm talking about the ways back 91. Those days, a digitizer which was actually capable of receiving the signal from few channels, and it can convert the data into the digital form, and it was trying to store the data in the form of floppies. Okay, so it was actually such a huge money need to be invested on that, and nowadays it has become very simple and easy, and it is even possible for us to handle complex varieties of data. Anyway, in order to convert the analog form of data into the digital form, it is trying to take the support of analog to digital converter. The converter might be, that's what I said, if you try to take a digital camera, The converter is actually a part of your camera now. Okay. Anyway, so at the front end of the frame grabber it has been. What is this frame grabber? It is an image storage and computation device that stores the data of a given pixel array. So your frame grabber is trying to store the data in the digital form. So once you have the data in the digital form, in the sense that data is going to be, as we have discussed in the earlier slides, the data is going to be like pixel information pertaining to the array of pixel. Data pertaining to the array of pixels. That information if you store, okay, so the device that stores is actually frame grabber. And of course, the storage capacity is going to vary based on its capacity. Powerful frame grabbers can also be straight away used to perform thresholding, windowing, and histogram modifications. See, light intensities, whatever have been referred into, taking into aspects of those things, if you try to develop a histogram, and that particular histogram is going to deal with such a kind of plot. Thresholding, anyway, I have told you that it is going to convert the entire image, irrespective of the colors, it is going to convert that into binary form, black or white, so that the array of pixel information, whatever is being stored, it's going to be totally with either 0 or 1. The stored image can be processed and analyzed by the combination of frame grabber and the vision controller. Okay. Anyway, the controller is the one what is trying to take the support of frame grabber in order to manage the data, manipulate the data, or rather to understand that particular data. And we have been using the camera once that particular term has come. It is time for us to discuss about the device that has been used to capture the image. And of course, in the bookish format we are trying to, and in which we are trying to consider the camera which was used in the olden days, that was trying to capture image only in the black and white form, that has been referred with a name called Vidicon. And of course, the development, maybe by the time the author has recorded, the development was taking the support of solid state switches. So solid state, that's the reason why it has been stated as solid state cameras. So what does the solid state cameras are trying to take into account? That was trying to take the support of either CCD or CID. What is this CCD? CCD is nothing but charge coupled device. CID is nothing but charge injection device. So when CID term has come, we may go to some other investigation agency. But here with respect to the imaging device, it is actually solid state cameras are trying to take the support of, they are working with the support of either CCT, charge coupled devices, or CID, charge injection devices. And there is another technique, that is actually silicon bipolar sensor cameras. So these three are the basics on which the solid state cameras are trying to provide vision to the road. So if you go into the structural information of Vidicon camera, this is not Videocon, this is Vidicon camera. You can see here, you are going to have a lens. Obviously, you are going to have a lens. You are having a lens here. You are having a scene, and on lens, you know what happens to the scene that is going to be reversed, that is known to us. And you have got a mesh, and you have got glass plate, face plate, and this particular glass plate, face plate, is going to be coated with two layers. We will see that information in the description. So this particular glass face plate is going to be coated with the two layers. and you have got electron gun, and this particular electron gun will be made to eject the beam, and that particular beam will try to scan the entire screen in a systematic manner. Such a kind of approach is being referred as raster scan. So it scan the entire screen in order to ensure that the image has been made visible to us as if it is there as such. Even the information whatever you are actually watching on screen now, maybe you are all, I am expecting that you are all sitting in front of your computers. On your computer, the screen image or information whatever is getting displayed, that is not continuously available on screen just like that, like a photo. It has been scanned, refreshed. That way you try to imagine. It is getting refreshed, and it is giving us a feel as if it is continuously available over there. Okay. So anyway, you have got focusing coil. This focusing coil will try to focus that particular beam. So this is how it is actually the inner details that are all available with this. If you try to see its working, uh, the lens is actually forming an image on the glass faceplate of the camera. That is what it is trying to do. See, lens is trying to arrange the image on the glass faceplate. Okay, the inner surface of the faceplate was coated with two layers. That means this side is actually being coated with two layers. First layer is what? Transparent signal electrode film. Transparent signal electrode film. Second layer is thin photosensitive material. Okay, so it is actually capable of sensing that what you call beam, and it can react based on it. Is going to illuminate based on that. That is what is actually happening at the second layer. In the first layer, transparent signal electrode film, okay, and it is going to be energized, and such an energized thing is going to have certain level of information, and that information is going to be sensed by the photosensitive material. And the photosensitive layer consists of high density of small areas. Please be careful. High density of small areas like pixels, not pixels. Like pixels. The purpose that is being served by the pixels, similar purpose is getting served even over here. So the photosensitive layer, that is second layer, is going to have so many number of small high density areas. They are going to function, their function is going to serve like pixels but not pixels. Each area generates a decreasing electrical resistance. So the purpose of identifying small areas are in order to generate electrical resistance. Small areas, for suppose the total image was subdivided into 1,000 small areas, say. So at each and every area, maybe area 1 to area 1,000. Okay, area N is going to have some electrical resistance. And how much that electrical resistance is going to be? That is depending on the value of illumination. More and more is the illumination, lesser is the electrical resistance. Okay, so this is how the purpose that is being served by the photosensitive material, that too, it has been accommodated with small areas, and the purpose that is being served with that is actually something similar to the pixels, and it is going to generate electrical resistance. Lesser is going to be the resistance when there is more illumination on that area. Okay, so that is how it is. A charge is created in each small area that is corresponding to the illumination. Thus, what is happening? A pattern of electrical charges have been generated, because A1 is going to have some electrical charge, A2 something else, A3 something else, likewise up to AN. Okay. And of course, all this particular charge is corresponding to the image that has been made to fall with the support of lens on the faceplate. And this particular charge that is accumulated for an area is a function of the intensity of impinging light over a specified period of time. So the time dependency is also there. So its relation or its function is also there with respect to the time. So by getting this particular link, what is going to happen? We'll see in the next slides. We will see how this particular time is getting manipulated. Soon after the charge is built up, it is read out to produce ready to produce a video signal. This is accomplished by scanning the photosensitive layer by an electron beam. See here, we are trying to produce an electron beam from here that has been focused with the support of a focusing coil, and that beam is going to read the charge whatever has been created on an area. Okay, not only on a small area, all such small areas are going to be energized. Maybe some electrical resistance would have got developed. So this particular scanning process, the electron beam is going to be made to pass through that entire photosensitive layer. It reads that entire information. And of course, that particular scanning is being controlled by deflection coil. See, when you want to adjust it from line to line, or even that within that particular line, when you want to move that particular beam either from left to right or from right to left. Okay, so focusing coil is actually to focus and to move along the line by line, and within the line either from left to right or so. All that has been taken care with the support of deflection coil. Okay, so now, so this particular scanning method has been referred as raster scanning. That is going to make the entire areas of that particular photosensitive material to what you call read. Okay, so that the total information within a short period of time it will be able to gather pertaining to that particular time span. Means that particular scanning is not going to be done just once and kept quiet. Maybe at an instance it is going to scan the entire area information, and again that information is going to be stored, and in the second instance the level of scanning is going to happen such that it is not going to give us any feel that the image is not, that the image is going to be continuously being displayed on screen. Okay, such a small span of time is going to be taken to complete that entire scanning. Anyway, so raster scanning is typically done by scanning the electronic beam from left to right and top to bottom. See, the directions earlier we were not clear, but right now those directions have been stated. So for the fixed scan time, the charge accumulated is proportional to the intensity of that portion of image being considered. This is obvious because area by area, small areas by areas, their intensities are providing a scope for charging those areas. More is the intensity, less is the charge. That's what we have noticed. Okay, based on that scanned information, we will be able to know the charge. Once charge is less, obviously the intensity at that location of that particular portion of the image is going to be more. So altogether, the output of the camera is a continuous voltage signal for each line being scanned, and this signal is subsequently sampled and quantized, resulting in a series of sampled voltages being stored in digital memory. That's what I said. Every time it is being scanned, it is going to get a set of data pertaining to that particular frame of information. So it is not going to stop its scanning, it is going to be continued. Whenever it has scanned another set of frame, likewise, thousands of sets of frame of information is going to be made available for us. So in that particular process, if you consider a two-dimensional array of picture elements, normally one pixel information is going to be quantized between 6 to 8 bits. Okay, means 2 power 6 to 2 power 8 volume of data is going to be extracted. Now let us see how, okay, sorry, it is already 9, what is the time now? 9:44.
So 9:44, sir.
Yeah, I'll stop because next class is also there. Let me take attendance